Okay, we're gonna go ahead and get started. So I hope everyone is doing good today. Um, so you were supposed to do the week 6 sections on your own. For those of you who finished, how did you find them? Uh, were they good? Not too good? Anyone had any difficulty with any particular section? Because if someone did, we could look over. We could look at it before we do the labs. So no, everyone's doing good. Okay. Well, when it comes to functions, I find that functions are probably one of the most useful things in C++ because if you were writing a simple program, having all of your code in the main function could work. But if you were writing a more complicated program and you were repeating the same code over and over, it's a good idea to make a function out of it and then just call the function whenever you need to. So I was looking at the labs and I chose three that I liked. Two of them are very quick, and this one here, the one that's called driving costs, uh, I chose that one because it's very similar to a previous lab that we did before. Okay, so without any further ado, let's start looking at them. Which one do you want to do first? I unlocked 612, 613, and 614.
12.
Huh?
12.
12? Okay. Okay, great. So lab 612 says step count. So a pedometer treats walking 2,000 steps as walking 1 mile. Okay. Write a program whose input is the number of steps and whose output is the number of miles walked. Okay. Output each floating point value with 2 digits after the decimal point, which can be achieved by executing this line of code. Well, you already knew that, right? And for example, if the input is this, the output would be this, which is essentially this number divided by 2,000, right? Now, you could put the code all in your int main, but uh, this this particular lab wants us to do it in the form of a user-defined function that returns a double, and the function is called steps to miles, which accepts an input of type int, and which will be called user steps, right? So here's how we're gonna do it. You can see that it says define your function here, and then type your code here. Okay. So what we could do is write our int main, right? We could write our int main and then define the function afterwards. I think that's a good idea, right? So the user needs to input something. So I guess the first thing we'll do is make a variable of type int. What do you want to call this int? This variable is going to track the number of steps. What would you like to call it? Maybe just num steps like this. Like that. Or steps like Jose Garcia says. Yeah, sure. That works. And then we need to prompt our user to input the number of steps, right? So maybe we'll say cin. Now, the way we would calculate this is that we would take steps and divide it by 2,000, right? But here's the catch. This lab wants us to do it in the user-defined function. Okay? So let's actually start writing our user-defined function here, okay? So the program must define and call a function that returns a double. It's going to be called steps to miles and needs an input called user steps, okay? So here's what I'm going to do. I'm going to copy this, put it here, and then put our squiggly braces here. Now here we need to start coding the definition of the function, okay? So it needs to call the function. So even though I didn't define the function yet, let's go ahead and call it here. We're going to say x 2 miles. And then, so before I go any further, I should ask a question. How far did Professor Amir go with user-defined functions? The reason I'm asking is because if some information is needed before I go any further, like if something seems confusing, I should tell you guys beforehand. Anyone? Okay. Well, basically, this is the way a function works. Okay. Functions always have. We define this as a function, right? And functions always have open close parentheses. And here in the function definition, we actually stipulated that this particular function needs to accept one argument. The argument in this case, it needs to be of type int, and it's going to be called user steps. So the int that I need to put inside here is going to be steps, right? Like that. So what happens as a result is that when the compiler reaches line 17, because it sees a function, it will jump to the function definition, and steps will be accepted as the variable user steps, okay? Okay. So what I need to do now is return a double, which is going to be equal to user steps divided by 2,000, right? So that seems easy enough, right? So how about somebody one of you guys tell me what to type? It's actually quite easy. I'm just putting my code in the function instead of in the int main. Well, I put in here. Well, yeah, steps divided by 2,000, right? But I actually, thank you, Slayman Toki, but I actually need to, yeah, something like that. But I think a good idea is to declare a double. Yeah, it's exactly what Logan James Ashbaugh says in the chat. So we should use 2000.0 so that we're using integer double division instead of integer division. So I say the first thing we're going to do is declare a double variable. So let's say double. And we need to give this double variable a name. What do you want to call it? Maybe just output is fine. Is that okay? shouldn't the function have int steps instead of int user steps? Uh, that's a good question, Arto Perez. And the answer is no, because here's the thing. Steps is the variable that I'm passing into the function, but user steps is the name of the variable that the function accepts. You see, this is a user-defined functions are a general thing. So what happens as a result is that whatever values in steps will be passed as user steps, and then the function will use user steps as the variable in the function, right? Because if I call this function, I might not pass steps into it. I might pass something else. I could pass any integer value into this variable, to be honest. But I say user steps because, well, not only does it say to use it here, but this is supposed to be like a general case that you use for anywhere in your program. So I'm gonna say double output, and then I'm gonna say output equals, and then we're gonna do what Slayman Toki said in the chat. We're gonna say steps divided by 2000, except in this case, I'm not gonna use steps because that's outside the scope of this function. I need to use user steps. User steps divided by 2000. Now, this should interpret as double division because output is a double. But we're going to do what Logan Ashbaugh said in the chat and put a 0.0.
And you said it's user steps because it's before int main?
It's because the only time I declared steps was in the main function. So steps is a variable that's in the scope of the main function.
Okay, got it.
If I said steps in here, the function will not know what it is.
Okay, so this is two different steps then.
Yeah, there's
Okay.
there's two functions in this program. One is the main
Uh-huh.
function, and one is the steps to mouse function.
Mhm.
The way you should think about it is that, like, imagine there's two different workers working on the same job, but the work of one, and the work is being distributed between those two functions, but what one function does is completely unknown to the other function. Well, I can talk about this further after we finish this.
Okay, of course. But I got it. I understood it. Thank you.
Yeah, you're welcome. So now that we got that, since this function is of type double, this function needs to return a double. Now, how many of you did the section called return on the chapter 6 sections? It goes over it in depth what the return keyword does. Okay, well, essentially what I need to do, since this function needs to return a double, I'm going to say return, and then I'm going to output my output here, right? Now, the object that this is returning is going to be output, which is of type double. And that's good because I just stipulated that this function will return a double, right? So essentially, this function definition is complete. So what happens now is that I need to see out how many miles the steps is. But in order to do that, what I need to do is realize that because the function is of type double, I need to treat it as a double. And so if I'm going to treat this as a double variable, in order for me to see its contents, I need to see out it the same way I would with any double variable. Like right here in line 20, I will say cout dev just like. And then I think I need to end the line in order for this to work, right? Because all of our labs needed to end with a end line. So I believe that this this will work now. So let's take a moment to think about how this would work step by step. So we have an int called steps. We have a so our main function is the first worker, right? Main declares a variable called steps. It prompts the user to see in it, and then our main function calls the steps to mouse function and says, hey, I need you to do this, do your job, and then take this variable as your argument, right? So whatever steps was, let's say it was 5,345, this value will be passed to user steps. Okay, so now our other worker is working. So steps to mouse takes user steps, which was equal to what steps was equal to. It takes it and divides it by 2,000 and then returns it. Okay. So what happens as a result is that this value here is going to be equal to whatever this outputs. So what do you guys think? This will work? How many of you think this will work?
I think it'll work.
You think it'll work? I think it'll work too.
Yeah.
Oh, you know what? I forgot something very important. It said in the instructions that I need to include this as the very first line. And that's the reason why some of these tests failed, because input is not precise to 2 decimal points. So let me go ahead and quickly fix that. So I will take this and have it be the very first line of my int. Now it'll work. There we go. All right, so
And that what you just printed into the coding is just make sure it's only 2 decimal places.
yeah, this makes sure that any numeric value that we output shows only the 2 decimal points.
And we have to put it in the beginning, or we have to put it just before the other count?
We should put it in the beginning.
Okay.
Or we output anything.
Understood. Thank you.
Okay, so yeah, so there's that. So go ahead and do what you need to in order to get this code. I hope everything makes sense. Before we move on to the next lab, I'm going to show you a couple things about functions. Did everybody get this already? Are we good?
Yeah.
Okay, I'm going to assume everyone's good. So let me take a quick second to, I'm going to go back real fast. Let me, there. Now we did this lab just now, but before we go any further, I'd like to go over a couple things about functions because there seemed to be a little bit of confusion, I think. Now, I'll just call this functions. I'll just call this int name. So let's say that so the reason why functions are helpful is because we can partition the work that a program does and split it between functions, right? If we're doing something repetitive, some sort of code that's repetitive over and over, it's a good idea to make it as a function and have your int main function call that function so that you're not repeating the same code over and over. So let's say that I want to take a bunch of integers like a equals int a equals 5, int b equals 6, int b equals 7, like that. Now I want to know what's I want to see out what a and b is, a and c is, and what b and c is. So yeah, it's a plus b and c and b plus c, like that. See? Now, if I wanted to, this code is simple enough that I could have it in the int main. Like inside of these chevrons, I could say a plus b, a plus c, and then b plus c here, right? Now, this would work just fine. So 5 plus 6 is 11, 5 plus 7 is 12, 6 plus 7 is 13, right? But what if I didn't want to have the work be in the int main? What if I wanted to write a function that takes two integers and then adds them together? So because I need this function to return an int, this function is going to be of type int. And I guess we need to give this function a name. So I'll probably say add to int, like that. Now, the parameters that the arguments that I need to pass to this, they're both going to be of type int. So int. Now, the arguments are general. So I need to give them names that are kind of general. So maybe I'll name these int 1 and int 2, like that. So whatever gets passed in here, I'm going to have to return something that's of type int. So I'm going to say return int 1 plus int 2, like that. And then I can use this function instead of this. So I might say, I'm going to call my function here, and instead of saying this, I'm going to say a and b. A and C, and then B and C. Do we understand how this works? So in this first instance, A is being passed as int1, and then B is being passed as int2. So if I actually ran this, well, I'm going to debug it. So what happens here is that when I get to line 16, the compiler will jump to the function definition because it's being called, right? So it'll jump straight to here. In this situation, int1 is equal to 5 because that's what I passed to it, and int2 is equal to 6 because that's what I passed to it. When I do the calculation, it'll take 5 and 6 together and return that value. So it'll see out 11 because that's what it returned, right? When I call the function again, this time the arguments are different. I'm passing A and C. So when it jumps to the definition, int1 currently is equal to 5, but int2 is equal to 7. So it'll return 5 plus 7, and that's what we get. See? And when we call it again, this time int1 is equal to B and int2 is equal to C, which is equal to 6 and 7 respectively. So when I return, it'll output 13. So now we understand how user-defined functions will work. And we can call this function anytime we want, and that's the reason why it's so useful. Okay. But I think that's enough of that. Let's go to the next lab. So you guys want to do this one next, 614, because it's actually also very easy. Okay. So this is lab 6.14, max magnitude. So this one says, write a function called max magnitude with 2 integer input parameters that returns the largest magnitude value. Use the function in the program that takes 2 integer inputs and outputs the largest magnitude value. So if the arguments that you input is 5 and 7, the function needs to return the 7 because it's the larger of the 2 values. Okay. Well, I shouldn't say larger because we're dealing with the magnitude, which is essentially distance from 0, right? And then in another example, if the inputs are -8 and -2, the function needs to return the -8 because it has a larger magnitude. It has a greater distance from 0, right? Now, even though we could, this program is simple enough that we could have the code in the int main. We're gonna do what the lab tells us to do and actually make a function that does exactly what we're trying to do, where we pass the parameters to the function and have the function do the work. Okay. So what do you guys want to do? Do you want to write the function first, or do you want to write the int main first? It doesn't really matter which one we do first. Someone say in the chat what do you think we should do first? You want to do the function first? Okay. So the function form looks like this. So I'm just going to copy this and put it in here. Okay. Now I need squiggly brackets. So I'm going to put that here. That. So my parameters are called user val 1 and user val 2. How would I find which one has a greater magnitude? If statement, exactly. So I think Aaron Massey says I need to include C math. Do I have to? I guess it wouldn't hurt. Include C math. Oh yeah, you're right. I actually forgot that the absolute value function is a member of the C math library. So thank you for that, Aaron Massey. This is why. If you guys ever get jobs as software engineers, you're almost never working alone. You have a team of software engineers that are helping you. So this is always helpful. So so here's where how we're gonna do it. So if, and I need to check if the absolute value of val 1 is going to be greater than the absolute value of val 2, right? So the way I'm going to do that is if abs user val 1 is greater than abs user val 2, like that. So if this is true, if this evaluates to be true, it means that user val 1 has a greater magnitude than user val 2. And if that's the case, I need to return user val 1, right? So I'm going to say return user val 2. Or excuse me, 1. So that's the if this is true. But what if it's not true? I'm going to need an else, right? And inside of this else, I'm just going to say, I'm just going to return the other variable that wasn't returned last time. So I'm going to say return user val 2. Like that. See? And I guess for the sake of consistency, I'll just put the same comment that I put here and just switch the 2 and the 1 around. Okay. So this looks good. It looks to me like my user-defined function is finished. Okay. So now that this function is ready to use, let's start writing my int main now. So how would I go about this? Well, first and foremost, the int main function needs the user to input 2 values, right? So I'm probably going to declare some ints. What do you want to call these ints? Ints.
Can we name them the same thing?
You could name them the same thing if you want. User val 1 and user val 2. Like that. But what you need to understand is that this user val 1 and 2 belongs to the scope of the int main. And this user val 1 and user val 2 belong to the scope of max magnitude. Just keep that in mind, okay? So, so I guess we'll see in user val1, and then user val2, right? Okay. Now, what we need to do is output the magnitude, but we already wrote a function that does exactly that, right? So instead of saying this code again, let's just call the function because we just wrote it, right? We better use it. So I say we're going to call the function max magnitude, but we need to pass the two variables into it. So I'm going to say user val1 and user val2, like that. And what happens as a result is that these two parameters will be passed into this function. Now, this program looks good so far, but I'm actually missing one thing. Can anyone tell me what it is? There's one thing that's
It's an integer. Max magnitude is an integer. You haven't assigned it to anything.
Yeah, you're right. So this actually wouldn't show in the outputs. So I didn't assign it to anything, but here's the thing. I actually don't have to. Because I'm trying to return it. I'm trying to show it to the screen. Since this is an int value, what I can do is treat it like an integer value and just see out it like that. Now, what you were saying was something like, you were probably going to say something along the lines of int output, and then have max magnitude equal to output. And then just see output. You were probably going to suggest something like that, right?
Something like that.
Something like this. Yeah. But you actually don't need to. You can just skip this variable entirely and just see out the magnitude of it. In other words, just do this. And this is acceptable. Well, the reason I said that is because yeah, the reason you don't need to add it, Slayman Togi, is just that he was making, someone else was making the suggestion that you should set it equal to something. That's why. But yeah, here is our finished program. We have two functions that are doing separate processes. Okay. So how many of you think that doesn't work?
It needs to have an endl.
Oh yeah, you're right. Thank you for reminding me. Perfect. So now how many of you think this will work? Okay. So it looks like you guys think it'll work. So let's go ahead and submit this and let's see what we get. Yep, it works. So here's what we got. So take a screenshot, do whatever you need to get in order to get this code. But yeah. I hope we all understand the mechanics of all this. The int main takes input from the user, while the int magnitude does the actual logic. But yeah, if we're good, we can move on to the very last lab. So I'll go ahead and go back. This one. This is the last lab, 613 driving costs. So this one says, write a function driving cost with input parameters driven miles, miles per gallon, and dollars per gallon, right? That returns a dollar cost to drive those miles. All items are of type double. So this is a double, this is a double, this is a double, and the thing that we're going to return is a double as well. So if the function is called with 50 as the driven miles, 20 as the miles per gallon, and then 3.1599 is the dollars per gallon, that returns the dollar cost to drive those miles. Okay. Now, one thing you might notice is that this lab is exactly the same as one of the labs that we did previously. The only thing that we're changing is that we're putting the math operations inside of a function instead of doing it in the int main. And that's the only difference. Okay. So define that function in the program whose inputs are the car's miles per gallon and the gallons per dollar, gas dollars per gallon. I'll put the gas cost for 10, 50, and 400 miles. Okay. So if the input is this, it'll output these. Okay. So looks like so the function needs to be in this form. So I'm going to copy this and put it here, right? I'll put my within brackets. So I think what I want to do is write my int main first. Okay. So I'm going to need two doubles. One is going to be the miles per gallon. The other is going to be dollars per gallon, right? So I'll say double miles per gallon. And then double dollars per gallon, right? Now, actually, I just realized something. Before we do anything, I should actually say this line of code first. That way, every numeric value that I output is going to be precise to 2 decimal points. So let me just quickly take this and put it here before anything else. There we go. Okay, so far so good. Now, what we need to do is output, after we get the miles per gallon and dollars per gallon, we need to output the cost for driving 10 miles, 50 miles, and 400 miles. Okay. So here's what I suggest we do. Let's finish writing the int main first. And then after that, we can better visualize the way we want our function driving costs to work. Okay. So I say we're going to see out deriving cost now driving cost requires 3 parameters, right? The first one's going to be driven miles, then miles per gallon, and dollars per gallon. So I'm actually going to call the function 3 times, right? But of those 3 times I'm calling it, the parameters I'm going to be passing to it is going to be different each time. So I'm going to separate this with commas. That. Now, the first parameter is going to be driven miles. And that's the thing that's going to be different because in the first instance, it's going to be 10 miles, then 50 miles, then 400 miles. So I'm going to put 10 in here, 50 here, and then 400 here. This is the part that's changing. The part that's not changing is the miles per gallon in the second parameter. And then the dollars per gallon in the third parameter, right? So yeah, like that. So at this point in time, you can see the usefulness of writing a function and just calling it whenever you need to, right? Because if I wasn't doing this as a function, I would be repeating the same code 3 times over, and no one wants to do that, right? So now that our int main is finished, we could actually, it's not finished. I need to put spaces in between. And then L2. I actually have the NL over here. Yeah. So we can start writing our function definition, right? So how are we gonna do this? So I believe that the way we did this before is that we took the number of miles and divided it by the number of miles per gallon, and then multiplied that by the number of dollars per gallon, right? So I think that's the way we did it, right? When we did the lab the first time. So we take derivative minus divide it by miles per gallon. So if we got that, we were left with the gallons, right? And then we multiply that by dollars per gallon. And then we just have to see out this, right? Or not see out, we have to return it. My mind was still fixated on the writing the int main. If I can spell return correctly. And I think that's it. So before I actually run this, let's try to visualize the way that this is working, okay? So int main calls the function driving costs the first time. 10 is being passed as driven miles. Whatever the user inputted before, actually, I forgot to prompt the user to see in them. So So miles per gallon is going to be equal to whatever the user inputted, and dollars per gallon is going to be equal to whatever the user inputted, right? It'll take this and do the calculation. The calculation is always going to be the number of miles driven divided by this value and then multiplied by this value, right? That'll be one value. Then I see out a space because that's what it wants us to do, right? And then return the number of the cost when it's 50 miles. So int main will call the function again. This time, the arguments are slightly different. Instead of 10 miles driven, it's going to be 50 miles driven. See? It'll do the calculation and then return that value along with a space. And then we call the function one more time. This time, the number of miles driven is going to be equal to 400. So it'll be 400 divided by user input divided times user input. And then lastly, we end out. So this lab illustrates the usefulness of defining functions, right? Because in the last version of this lab that we did, we only did the calculation once, right? If we wanted to do the calculation 2 additional times, if we didn't have knowledge of user-defined functions, we would have to repeat the same code twice. But we actually didn't need to repeat the code because we had the code done in the user-defined function. Okay. So what do you guys think? Do we think this will work? Say in the chat if you think it'll work or not. Do you think it'll work? Okay. So a lot of people seem to agree that this will work. Well, there's only one way of finding out, right? So let's go ahead and submit this and see what we get. Yep, it works. So looking at these tests, if this was the miles per, if this was the miles per gallon, this was the dollars per gallon, this is the cost of driving 10 miles, then 50 miles, then 400 miles. If this was the miles per gallon, and this was the dollars per gallon, this is the cost of driving 10 miles, then 50 miles, then 400 miles. Okay, great. So yeah, so here is the code in order to do it. It's very simple, actually. So go ahead and take screenshots or do whatever you need in order to get this. So what did everyone get this already? And of course, I will be putting the video of this on Blackboard momentarily. Okay, perfect. Everyone got it. So I hope everyone found this very educational. I hope I hope everyone understands the the usefulness of user-defined functions. It prevents us from having to repeat the same code over and over. All right. So if everyone got this, unless anyone has any other questions, like questions pertaining to the code or questions pertaining to the sections, I think we're just about ready to wrap up this meeting. Okay. You're welcome, Christopher Gutierrez. But if nobody has any further questions, I think we're good to wrap this up. This is going, like, the labs as well as the work in the sections, it's all going to be due on the 11th. So 5 p.m. Thursday. So make sure you do this before that deadline. Yeah, the sections as well as the 3 labs that I undid. But if nobody else needs anything else, yeah, I think we're ready to wrap this up. So stop sharing.
Thanks for today's lesson, Professor.
Huh?
Thanks for the lesson.
Oh, you're welcome. But yeah, so I'll see you guys on Thursday. So have a good night, everyone.